Okay, so today what we're going to try and do is we're going to try and do something a little different. We did work on our review guide today during class. Students had the choice to either, you can't see it on this board over here, to work on the Delta Math review guide. They could finish their Chapter 3 notes, update their Chapter 2 notes for the late credit, or finish their vocabulary words for tomorrow's vocab quiz. One of those several options. Most of them, by the time they were done updating everything else, started to work on this, and there were a lot of questions about, I don't know how to do this, or I've never seen this before, normal questions that we get on any day of review. 90% of what we've done here is done exactly like we've done in class. There were a few at the very beginning. There were graphing basics questions just to see how the students were doing on the skills before we move into the next part. So I thought I'd introduce what I would like to call a lightning fire round to see how many of these we can get through. So I'm going to go through these questions. I'm going to spend 1 minute on each one of these topics. If we get through multiple questions, we do. If not, we'll just get through as much as we can. I'm going to try and spend 1 minute at least getting you set up. So this isn't meant to be a long and lengthy video, but we're about to get started here in just a moment, here in about 15 seconds. So I'm going to go ahead and get started with plotting points. Scroll down here in just a minute. And we're going to get started in 5, 4, 3, 2, 1. Let's go. So plotting the points, this is basically just recognizing to see, do we know left and right, up and down? So I'm going to go ahead and I'm going to say, hey, for this point, I need to go right 7 and then up 6. And then I just pop that point, submit my answer. Boom. That's all that we're doing on these. The penalty is back to 0 because this is, again, very basics of graphing. Do they know where the coordinates are? Plot the point 0, 5, which means stay in the center and go up 5. Let's see, we're about halfway. Let's go to the next problem. This one says 2, 6, so I'm going to the right 2 and up 6. So right 2, up 6. Also, half the time it's learning how to submit the problems for these style questions. That's a big problem that students have, is they're like, I know how to do it, but I don't know how to do the answer. So this is 1, 6, go right 1, up 6, pop the point. Let's submit our answers. Awesome, we're about to go to the next problem. Oh, nope, we are out of time. So let's go ahead and jump over to get the mouse over here, plotting points on a scale. So this is 7/10. So you notice there aren't actually spaces in here. We have to measure the distance within these gaps. Let's actually move one of these desks so I can look a little bit better at the board. So for 7/10, I'm going to be between these two values and pop my point right there. Submit my answer. I got that one correct. Now, a lot of students had issues with this one today because they weren't clicking exactly. Like 0.81, this is going to be just above the 80. So I'm going to be really, really close to the 80. Sometimes students were dragging it like a little off, and it was not really sure what just happened there, and it was kicking them back as wrong. We got 15 seconds. Let's see if we can't get it. So 11:38, here's one that might have given problems. 11, let's go all the way up to 38, which is going to be somewhat close to 40. Do we have time? Yes, we do. Awesome, that's all we're doing. And again, this was a little finicky because you needed to be pretty close to where you're supposed to be. That's the end of time on this one. Let's go to graphing stories. Students did not like this one today because it involved reading. In essence, let's go ahead and take this piece by piece. One spring day, I'll notice the time of day and the temperature in degrees in Fahrenheit. Her findings are as follows. At 6 a.m., the temperature was 56 degrees. So we're going to plot a point right there. At 6 a.m., the temperature is, we said it was 56 degrees. So I'm going to go to 6 a.m. and go to 56 degrees. And you see how it's waiting for the next point. And then for the next 2 hours, the temperature rose at 3 degrees per hour. So that means after 2 hours, I would be at 3 and another 3, so I would be at 62. Ooh, I'm running out of time. So 6, that's 12, so 7, 8, 9, 10, 11, so 6, 7, 8. I went up 1, 2, 3, 4, 5, 6. There we go. And the temperature rose, and we're just connecting those dots. But we're over on time, so I'm going to go ahead and I'm going to do the next one. But that's all you're doing on these things. This one was the same style. You're tracking the data as it goes. So I know I'll track the amount of snow on the ground. When the snow began, there were 3 inches of snow on the ground. So I'm going to go over here. When the snow began, there were 3 inches. I put a little dot at the 3. Snow fell at a constant rate of 1 inch every 2 hours until another 2 inches had fallen. So I would say 2 hours, I would put up another inch, 2 hours, another inch. So there we go. I've got those points right there. The storm then stopped for 2 hours and started again at a constant rate of 2 inches for the next 3 hours. So we stopped for 2 hours, which means I'm going to go 1, 2, boom. I have a flat line right there, and then it goes up another 1 inches every 2 hours for 3 hours. So I connect those. You see how it's creeping its way up. That's time right there, so we're going to jump off to the next one. Interpreting graph stories. This was another difficult one because you had to figure out where the variables are in relation to each other. During a snowstorm, the snow fell at a constant rate for a number of hours, then it stopped snowing for a number of hours, then it started up again at a different constant rate. Dominic made the graph showing the inches of snow on the ground over time using the data that he'd collected. So it started snowing, the snow went up over time, then it stopped, and then it started snowing, but it looks like it went up even faster. So it looks like it was heavier over on this part because the snow increased faster. How long did it stop snowing for? So what we're going to notice is this flat spot. We're supposed to identify that from 10 to 15, it had stopped snowing. So that's going to be for a grand total of 5 hours. Let's submit our answer, see how well we did on that one. My answer is not correct. Ooh, stopped snowing. That is from 10, 16. Okay, cool. I didn't even read the graph right. Hence, don't freak out. That's why we get 2 attempts on this thing. Boom, there we go. Oop, I'm a little over on time. Let's go ahead. Select the graphs matching story. This one gave a lot of students problems because all these graphs sometimes look really good. We have a cyclist traveling on a route from town A to town B. We want to see X is the distance from town A, Y is the distance from town B. So where we're going to start is if we're traveling from A to B, well, I'm in A, so my distance should start on the 0 mark. So all of these start on the 0 mark, which is perfect. But as I travel away from my town, the distance is going to get bigger. So I'm going to expect this distance to move to the right. But as I get to the right, I'm expecting my distance to get smaller in town B, which is the only one where it gets smaller, which means I'm getting closer to B as I move farther away from A. And so we're just interpreting that right there. So that's going to be graph D. Let's see if we're good because this is time. Awesome. Excellent. We don't have time to do the next problem. Let's jump up to domain and range. Was that the one? Yeah, domain and range. So now we're getting back into the ones that we practiced in class. Find the range of the function defined by the table below. Express your answer as a set of numbers. Remember, range is going to be our y values. So my range is 3 numbers. I have -2, 5, and 7. So -2, 5, and 7 are my 3 numbers there. Okay. Next problem. Find the range of the function as defined by the set of points. Remember, it is the y value. So I'm looking at the right number on all these because every coordinate is x comma y. So I have, let's see, I have -3. I have -4. Move my head out of the shadow here. I have -1, 6, 5. So I have -1, 6, 5. And then I have -1 again, so I'm not going to put it in there. I'm going to submit the answers right there. Awesome, that's it. That's also time. Visual domain and range. Determine the range. Remember, the range is the y values, so bottom to top. My minimum is 1, my maximum is 8. So it's between 1 and 8. But they want you to submit your answer as an inequality. So between 1 and 8, I have my y value. So I'm going to put my y between the 1 and the 8, but I need to show it as an inequality. So y is going to be greater than 1. And it's also going to be less than 8. So I have y set up between those 2 values right there. It's also including those 2 points. So let's actually pop in an equal sign right there because that's part of the graph. And let's submit those answers. Boom, we're good on that one. We got 10 seconds left. If I were to submit something like a domain, it's from left to right. So I'm saying from -6 all the way to +8. Domain is this direction. Don't have time. Let's go ahead and do the next one. This one is function and relation mapping diagrams. So what we're doing is we're testing 5 maps to 1, 2 maps to -2 and 6. Remember, we talked about these as coordinates. It's 5, 1, 2, -2, 2, -6, and 7, 4. That's how it maps out. This maps with that as a y. We notice the fact that the 2 is repeated. It has 2 lines coming from it, which means this is not a function, this is just a relationship. The mapping diagram above does not represent a function, since there is one number in set A, the input, one number in set A that maps to two numbers where there are multiple mappings to set B, the output. Basically what we're saying is, hey, one number maps to two numbers, which means this is not a function. Let's go ahead and test this out, make sure we're good on that one. Yep, we're good. I don't have time to do the next one, so let's go ahead and jump off to this. Determine if the set of points is a function. So which set of ordered pairs does not represent a function? So what I'm looking for on this one, just like before, is an x value that repeats itself. So I'm going to take a look at each one of these x values and see if I see another -6. No. Another 4. No. 1. No. 8. No. This is a function. The next one, 3. I don't see another 3. I don't see another -7. I don't see another -2. I don't see a 0. I'm only looking for the first number. I don't see another 1. I don't see another 0. I don't see another 2. I don't see another 6. -2. I do see another -2 here. So I've got a -2 here and here, and it maps to a 4 and a 5, which means that one input has two outputs. Something is happening in two places at the same time. So we don't like stuff like that. Let's try one more, see if we can't get it. Again, we're just trying to find an x value that repeats, which, let's see. Do I have, oops, see, I'm right in the first one. I have a -3 that maps to a 4 and a -3 that maps to the 9. So it's going to be that one right there. Just really quick finding that x that repeats, but that's also time. Let's determine if the graph is a function of level 1. Determine if the graph is a function. So determine whether it represents a function. Remember, we're doing our vertical line test. So I'm going to take my vertical line. If it touches the graph at 2 points, it's not a function. Because if it touches at 2 points, that means something is happening at two places at the same time. And it goes over and it says, hey, that's what we're doing right here. So with this one, if I drag it over the entirety of the function, it only touches at 1 point at any one time. So this graph does represent a function. That is a function. Yes. Awesome. And it goes through and it shows you visually again on that one. Last one. Do we have time? We have 10 seconds. We might get through this whole one. Determine whether the graph represents a function. We're going all the way through. That only touches at 1 every single time. So I'm going to say, yes, this is a function. Submit our answer. And yes, perfect. We're back up to time. We actually completed that entire topic in 1 minute. Determine if the graph is a function again. We're going to drag that vertical line across. It only touches once at any one place. So we're going to say the graph does represent a function because every input is mapped to a single output. That's the key phrase here. Every input is mapped to one output. As we drag it across, this is our input. Input of -10, input of -9, input of -8. It only touches one part of the graph. The graph is the output. So every time I map it, it only touches one spot. It only touches one output. If it touches more than one, it touches multiple outputs. Let's see if we can't get another one here in a minute. Yes, we are correct. It maps it through. Now with this one's also yes. It does represent a function because every input is mapped to a single output. Cool, we got 5 seconds left. Let's see if we can get one. That one again, it's very, very small, but it also does represent a function because every input is mapped to a single output. Boom, we close that out, and that is time. Function is increasing or decreasing. This one gave a few students problems, but then they tended to get it after they tried a few. Determine if the domain on which the following is decreasing. Remember, if we're riding a roller coaster, clack, 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 at this point is when we start plunging down. So this point is where we start decreasing. So I find the tip top, trace that all the way down from 4 to the bottom at 12, the function is decreasing. That roller coaster is going down. So from 4 to 12, the function is decreasing. I put an x between them because, again, we're going to say, hey, x is between 4 and 12. Now, it can't be decreasing at a point, so I'm not going to include them. I'm going to submit these answers, and boom, we're good. And see, it shows your arrows. You're plunging down. I don't have time because it is 3, 2, and 1. Let's go ahead and try the next one. Finding positive. So find the graph of y equals f of x is shown below. Find all values of x for which f of x is greater than 0. Now, it kind of gave you a key right here. It says y is equal to f of x. So it wants to know the parts where y is greater than 0. Where is y greater than 0? Anywhere in that point. Everywhere down there, my y's are negative. -1, -1, -2, -3, all the way down there. So my y values are going to be between -7 and -3. So my values for x is between -7 and -3. So -7 is less than x, which is less than -3. So we see that x is between those two numbers. Let's try this out. Boom, we got that. Do we have time? We have 10 seconds. Let's go ahead and we want to find the values for x which y is greater than 0. Remember, it gave you that little hint. Y is greater than 0, so I would include these points and those points. This would be an or. You would have the word or in your answer, but we don't have time to get into that because we're keeping it at 1 minute. The function f is graphed below. Determine the intervals on which f is increasing and decreasing. So when we look at this, again, increasing and decreasing means if you're riding a roller coaster, are you clickety-clacking up or are you plunging down screaming? Looks like all three of these pieces are you're plunging down screaming. So we're going to say the function is decreasing on the interval between, it's decreasing over the entire thing, so the leftmost point is -9, the rightmost point is +4. So between -9 and +4, it wants segment 1, so -9 to -3, it's decreasing. It's decreasing on the second segment, which is from -5 to -2. Oh, that's not a 3, that's a 5. So the function from -5 to -2, and we would input our answers like that, but we're out of time, so let's jump over here. Increasing versus positive graphically. So what we're looking at, the function is graphed below. What is true about the graph on the interval from point D to point E? So I'm looking only at this section right here from D to E, that little piece right there. If I'm riding a roller coaster, I'm plunging down. If I am looking at above or below the axis, it's above, so it's positive and it's plunging down. So that is going to be positive and decreasing. Okay. Let's take a look at the next one. So the next problem says we want to find between points E and F. So if we look at our graph between points E and F, it's that right there. That is still plunging down if I'm riding the roller coaster, but it's beneath the graph, so that's going to be decreasing because we're plunging down, but it's negative because we started out beneath the graph. Boom. That's going to be it on time. Let's come over here. Boom, and then that's it. So that's a really quick rendition. Now, they've had this all chapter. The reason why I didn't actually go through and answer every single one of these and go through these is these were assigned at the beginning of this chapter, so they've had this a little over a week. Today is the first day a lot of them opened this. So for good or for worse, they are now looking at it today. They're probably asking a lot of questions. I hope this gets the ball started. Again, remember, math class is not about me showing you how to do every step and you repeating it. You don't learn that way. A lot of it is about that uncomfortable struggle in the middle. Looking at this and trying to figure out how actually do I do this? I know how to do the skill. I saw the skill in class. How do I replicate that on this? Because when it comes time for the test or when it comes time for real life, life's not going to be like a math question. Life is going to be similar to this, and you need to figure out how do I take what I learned in school and recreate it similar to what I run into? How do I look at the test at the end of the year? Let's say we just want to look at it that way. The test is going to ask something similar to this. How do I take what we learned in class and compare it to what the test sounds like it's going to be asking? That's really what we want to do. So there's a little bit of uncomfortable struggle that a lot of students get really uncomfortable with, but embrace it. That struggle means that you are learning, you're making new connections. That's what it's all about. That's the name of the game, and you'll take that really far in life. So do well, study up, and I'll see you tomorrow for the test.